Collecting, treating. We'll start first with Mr. Weston from Rothshire Engineering.
Okay, great.
Perfect.
Thank you for connecting me. RSE are a complete turnkey water, first slide please, sorry. RSE are a complete turnkey water treatment engineering company. One of our key offerings and strengths in this field is a modular offsite build, which is of particular interest to remote, coastal and island environments. RSE have delivered 40 of these transportable treatment unit solutions to Scottish Water over the last 10 years. Complete water treatment systems are designed, manufactured, tested and pre-commissioned at our works in Scotland to be delivered to site and installed as plug and play. Single or multiple modules are based around a portal frame construction which can include any number of treatment technologies determined by the required capacity, the raw water source analysis and the specified clean water parameters. Next slide, please. To achieve this, we have to operate in a full 3D design for manufacturing and assembly modelling structure. Fabrication is in a clean, safe environment, ensuring high levels of health and safety, easy access to all engineering disciplines at one site, as well as consolidation of all deliveries and storage, reducing the project carbon footprint. Site civil requirements are reduced to a foundation structure and connections, which are prepared in tandem with the system build, thereby significantly reducing project program. Multi-units are disassembled for transport and reconnected at site, thereby significantly reducing site operational time and having minimal impact on the surrounding environment and infrastructure. The solution is built up from a library of standard products and designs, enable this solution to be both having a high degree of repeatability and scalability. Next slide, please. The example on this slide shows a beach landing delivery to the island of North Harris in the Outer Hebrides in Scotland. This island port did not have the infrastructure to receive the vessels of the size required for the treatment plant. The crane was deployed to the beach and the transportable treatment unit unloaded onto runners to move up the beach to the waiting road transport and then onto the pre-prepared site. These systems are significantly easy to deliver into rural and coastal areas due to the sheer transportability of the units. Thank you. Happy to answer any questions.
Thank you very much for your presentation. And so you were saying that this technology was implemented on northern European islands. Is there also some opportunities to export it in other places?
Yeah, absolutely. We haven't exported any outside of the UK yet, but we are talking to a number of remote countries about being able to supply these as they're all pre-produced. So, for example, we have opportunities that we're discovering at the moment in both Australia and New Zealand. So you couldn't get much further away from Scotland.
Okay. Thanks a lot, and Mr. Severio from Resolute Marine.
Thank you very much. Very exciting to be here today. So my name is Olivier Severio, and I'm a CEO and co-founder at Resolute Marine. Next slide, please. So in the world, 1 billion people lack safe access to drinking water, and as a result, 2.5 million die each year, mostly children. But the good news is that a large fraction of this population live in coastal areas where they have access to an incredible source of energy, ocean waves. And that's what we do at Resolute Marine Energy. We use ocean waves to drive a desalination system and provide fresh water for these people. Next slide. So the way it works is actually quite simple. First, you have a flap attached to the bottom of the seas that move back and forth with the waves. We extract energy from the wave, and we use it to pressurize seawater that we send to the shore, where it is used to directly drive a reverse osmosis process. So the main feature of our system is that it uses only ocean waves to produce fresh water, and there is no electricity in the manufacturing process. But though there is no electricity in the manufacturing process, we can actually co-generate electricity using pressurized seawater. And so the system that we are developing is an hybrid that can produce both water and power. At commercial stage, a system like the one shown here would produce an average of 4,000 cubic meters per day of fresh water. That's enough to cover the need of 40,000 people. And it would do that in our launch market by would reduce the cost of water by a third in our launch market. And I will explain on that. But what is really important for us also is that a system like that would actually displace another technology, diesel-driven desalination, that are often used in islands. And by displacing this technology would reduce carbon emission. So a system of 4,000 cubic meters per day of fresh water would actually reduce carbon emission by 4,000 tons per year. And that's the equivalent of taking 900 cars off the road. Next slide. So we are now currently working on our first commercial pilot in Cape Verde. This is a picture of the actual test site where we would like to test our technology. Cape Verde is an archipelago west of Africa. It's one of the driest countries in the world. It has no river, limited rain, and almost no aquifers. So as a result, in Cape Verde, 85% of the water is already desalinated. But because Cape Verde has no indigenous source of energy, they have to import all the oil necessary to drive this desalination system. And as a result, the cost of water in Cape Verde is one of the most expensive in the world. So a system like Wave 2 in Cape Verde could actually provide the country with a very cheap access to water, and also favor its trade balance and enable a thriving agriculture industry. So really, as a conclusion, we are developing a breakthrough technology that use ocean waves to produce fresh water and electricity, and could potentially impact the life of millions of people in island nations across the world. Thank you.
Thank you very much. So you were saying that your system is under development and maybe to be tested in Cabo Verde. And have you other plans to test this solution in
Yes,
some
of
other
course,
places, which is maybe with the same conditions as you were saying, with very dry ecosystems?
So we are currently testing the system in lab condition currently in the US now. Our next step is actually to test it in ocean condition in the Canary Island in a test site called Plocan, and then actually to test it in Cape Verde. So we have a roadmap, a technology roadmap that is pretty clear that we are trying to finance through grant and private investment, and to get to our commercial pilot in Cape Verde. In Cape Verde, the potential for our application is not limited only to, I would say, domestic water and agriculture, but way more like tourism, etc., bottled water even, etc. So there are many applications for us in Cape Verde.
Okay. Thank you very much. And I will move to the next speakers. And after, for sure, you stay with us to be part of the question and answer sessions. So now I give the floor to Madeleine Bell, which is going to talk to us about Desolator.
Good afternoon from London. Thank you for having me, Celine. And very proud to be working at Desolator, where we are not just a new technology for the water purification industry, but actually we have a whole new approach to how we can support water today and for future decades, when we are going to be up against lots of challenges, from climate change and rising sea levels to erratic rainfall. So today, the water landscape is dominated by models for vast, centralized, fossil fuel dependent technologies, which use a lot of consumables and chemicals, but most importantly produce water far away from the end user. So you then have a long supply chain via boats or tankers or plastic bottles, adding both cost and also environmental impact to your water. And a really hidden cost of water production is the vast amounts of chemicals which are used in purification, which then lead into, which are disposed of in oceans. So Desalinator has a new approach. We use 100% solar power, and we have this integrated system that uses no chemicals and provides water on site. So we're enabling a model of more distributed systems which can take a local water source, whether it's seawater or brackish water, and you can purify it on site and close to the end user. So next slide. So how do we do this? Well, we have a number of patents. You'll see here, this is a render of our systems which are being built at the moment. So we have a very efficient method of energy harvesting. So this solar array contains our patented PVT panels, which harness thermal as well as electrical energy from the sun. So what this means is they are 4 times more efficient than a standard solar panel. We also have patented our own multi-effect distillation vessels, which you can see just in the top right-hand corner of the picture. And these operate like a giant kettle, and this is where we distill whichever water source you have and turn it into clean water. And the benefit of this is that we don't need any filters or membranes, and we have a 95% reduction in the types of chemicals which are being used in traditional desalination technologies. We operate at scale at least 250,000 litres a day, but this is a modular system, so we can raise this depending on the need of the end user. And this quantity is really important because this enables us to produce water at a low levelized cost of $1 per cubic meter, because you have all your energy integrated, you don't need consumables, and we don't need chemicals either. So on to the last slide. So these are some pictures from the field. Next month, we're very excited to be going live with our project with the Dubai government. This is one of the most innovative water municipalities in the world, and we have a project we've been developing with them on one of their sites. And here are a few snapshots of what that will look like and when it is producing water. We're also working with Carlsberg to help them secure water in areas of water stress in their breweries around Asia. And we've also worked with other leading organizations such as Booking.com and AB InBev, who are trying to raise the standard of sustainability for the industries they work in. We've recently been recognized by the World Economic Forum as a transformative technology. We've been recognized by Tech for Islands for our ability to secure water for decades to come on islands at risk of climate change, increased hurricanes, which can contaminate freshwater sources, and where energy is very expensive. So please do get in touch if you have questions about how we can work together. And thank you for having me today.
Thank you very much. I was thinking that this solution may be difficult to implement in very tiny islands, but because it seems to be quite a big device. And what about the maintenance of such solution? Does the people who want to have this solution, does they need to have a regular contract with you, or is it possible for them to ensure the maintenance locally?
So this has been designed as a really low maintenance system. With traditional technologies, it's very tricky parts such as filters and membranes, which are the things that can get blocked more easily, whereas we have a distillation process or a thermal desalination process, so we eliminate those. And we also have some very nifty little features such as our panels have water running through them, which prevents overheating and means that they have a longer lifespan. So actually this is a system which is designed for very low maintenance and local training.
Okay, thank you very much.